Hello, everyone. Thank you for joining. And I'm really excited to unpack a topic that is, as we know, very hot these days, but also very near and dear to my interests for a while now. That is how we are testing LLMs and integrations with GenAI and modern software. So, My name is Rob Reagan. I'm a principal technology strategist with Bishop Fox. I've been in IT for 20 years. I've been in security for 15 years, and I've been researching and learning ML since 2018. I have been obsessed with GenAI since GPT-2, and I'm still working on those 10,000 hours of time using these technologies to really consider myself an expert. But I really want to share with you what I've been learning on that journey today. Um, I think an interesting thought experiment, though, is while we're fine tuning models, is AI course tuning us? Let's see what AI thinks of that. What do you think of the thought experiment that while we're fine tuning AI models, they are course tuning us?
That's a fascinating idea. It's true that as we fine tune AI models, we provide them with data and feedback that helps them better understand and interact with humans. At the same time, our interactions with AI can also shape our own behavior and ways of thinking. In a sense, AI models can act as a kind of mirror, reflecting back our own preferences and biases and potentially reinforcing them. This could be seen as a kind of coarse tuning of human behavior, though I think it's important to remember that humans are still in control and ultimately responsible for our own actions and choices. It's definitely a thought provoking idea and one that highlights the importance of being mindful about how we interact with AI and the potential impact that these interactions can have on our own thoughts and behavior.
Yeah, so that I think really sets the stage for why there is so much hype around Gen AI and how it is influencing our behavior. While there may be a lot of hype, I do firmly believe there is real practical use cases, and that's why we're seeing so much investment and so much development. For instance, this study actually compared consultants that were using AI versus did not use AI, and consultants that were using AI finished 12.2% more tasks on average and completed those tasks 25.1% more quickly and produced 40% higher quality results than those without. So maybe artificial intelligence isn't the best way to describe it. Maybe it's augmenting our own intelligence and changing our behavior for the better would be another way to look at it, at least in its current state. And I think that it's really proving that these performance numbers were bolstered even more whenever there was some training that had been done on how to properly use AI. And this is much more of a qualitative analysis rather than a quantitative analysis. Like for example, it's not how many questions like the AI could get right on the SAT tests. For example, it's more let's actually have other people evaluate the performance and the quality of the responses that were generated from these tasks. And I think this is a much better way to measure the performance of how we can augment our own abilities. But shifting into actually what it means to test these from a security perspective, again, this is really a collection of on my journey for working with our team here at Bishop Fox to develop our methodologies, to develop our own guidance, our own playbooks, and to really prescribe for our customers and their experience in building Gen AI into their applications. what they should be doing from an overall design perspective, from reviewing the implementation, perhaps APIs and source code, as well as the overall infrastructure. We're also going to explore what are common findings that we're encountering and what are actually viable and feasible mitigations and remediation techniques that would stand up to subsequent testing. I've also included in here some references and links to that get into the details of how these systems work and what they're actually doing. Uh, Definitely, you need a refresher on that. Would recommend these, and I think that what really clicks for me, in understanding this was this visualization of Gen AI orchestrating and producing a symphony. So actually, this I'm a very visual learner, and seeing folks say that, oh, it's just predicting the next word or it's just predicting the next token, but to see a visual representation of how a GPT can back reference to everything in its context window to then make a better prediction on what should come next. And in this case, a chord progression for those that are musically inclined, being able to build on what's going to sound good to come next based on what came before. This really clicked for me for visualizing the power and capabilities of Gen AI. So shifting into what you should consider whenever you're reviewing a application integration, the importance of this adoption really is going to be the evolution of traditional software engineering, where we were keeping source code and data separated, and we really had a separation of concerns around those two entities. And we were testing and versioning our source code, but we now we're going to evolve into a state where um, machine learning is part code, part data, and then the artifacts that are created by the two of those. You can say that the best data may win for organizations that have access to proprietary data and can build better machine learning capabilities around that. But also, I think the best user experience is likely to be what differentiates organizations in this space. Um, when it really comes down to targeting and testing an application, though, we really need to understand what the business requirements are, and then define around those business requirements what security objectives there are. Um, and these are always going to be at odds. It's always going to be, do you want your system to be more usable or to be more secure? One of these is helping the organization make money. One of these is often seen as a cost center for the organization. So they're always going to be. But let's dive a little bit deeper into what we're seeing as far as common use cases. So this is really, I'd say, in the last 6 months, whenever we've been testing LLM integrations, we're seeing a lot of organizations, first and foremost, really focus on improving their customer service experience. This has by far been the most common and popular use case, augmenting their FAQ systems. And other common scenarios are developing like an education platform that is having teachers generate lessons plans while integrating those with current events. We've seen security tool vendors and IT SaaS vendors generating and explaining summaries of their complex configuration files or rule sets. We've also seen natural language to be able to query financial data from the system, and then or perhaps generate a complex SQL query to retrieve that information from the data store by just having the end user describe it with natural language what they want. Where it gets much more interesting, though, is where we've seen chat ops platforms that are actually developing agency and giving Gen AI access to plugins. These plugins that can create and update and delete data is where, from a security perspective, it becomes, I think, a much more interesting set of test cases. So, from an overall process perspective, we really see this representing a much more comprehensive software development lifecycle for ML and AI integrations. Uh, this may seem very familiar to you, but it's what we're going to explore further here is how to apply doing architecture and security assessments and threat modeling at a design stage, or even if it's further along in the implementation stage, revisiting that and really helping the security team define where there are opportunities for improvement from an overall design perspective and what attacks they should expect to defend against. Um, when it comes to the implementation, we're really then just seeing if there are differences between the intended design and the implementation, and that's where there's often security vulnerabilities. We can focus on actually reviewing an API, something that may be part of a more traditional web user experience that has GenAI components, and reviewing the source code of that to really get a deep understanding of where there may be opportunities to exploit or where there's opportunities to build better mitigation layers in to defend against common attacks. And then, um, more as a third phase, we've been zooming out to the overall ML ops and looking at the process for how data is being managed to build and fine tune models, looking at how the infrastructure that's building the overall pipeline to service these applications is being secured, and really helping organizations practice their incident response capabilities to mitigate the risks of a breach on like a data science team, for example. So getting into the architecture and design, this is really where you're going to want to have a good definition of the overall trust boundaries of all the different components and really explore the principles of secure design, things like principle of least privilege or zero trust. Um, some things that are changing, I'd say, with LLM integrations and apps is it's really even a higher importance on trust boundaries. I know like a lot of folks were struggling with this in traditional software engineering, but now business logic flaws are becoming conversational logic flaws because a lot of access to data is happening at that LLM layer. And we really want to have a good definition from a design perspective of like what expected behavior there is, and then what abuse scenarios there are, and what fraudulent behavior we need to be catching and preventing. Having good logging and monitoring for this is going to be essential to have non-repudiation and be able to actually investigate incidents. So really, the process is those business requirements and mapping it to those security objectives. And this lays the groundwork for building a comprehensive test plan for all other phases of testing. Really starting out with building a overall diagram of all of the different entities that are involved, building an overall visualization that includes components that might be discovered from an SBOM, then understanding the data flow or relationships between those components can then ultimately help us establish intended trust boundaries and identify where security controls can be improved. So this is a diagram of like a recommendation for an enterprise RAG. There's really here two boxes that represent security layers, these guardrails for input and output. I think that really exploring and unpacking what that means and where else those types of security layers can be inserted can be helpful by going through this exercise. Um, Things that you can do as part of the overall architecture design that can really bolster security can be things like overall environment isolation. So ensuring that if there is an incident that occurs, it doesn't compromise other components of the system. One really interesting application of this that I've seen to mitigate prompt injection is a dual LLM pattern. This involves actually for a system that may have agency. In this case, it's an example of an email summarization tool. So this is going to have access to email, it's going to have access to read, and may lead to data leakage if not properly mitigated from prompt injection. A technique that may work well here is to actually apply a quarantine LLM that is handling untrusted user input, such as email, and a traditional software engineering controller where there's actually an allow list and a deny list of like what actions are specifically expected in this type of implementation and which of those that are prohibited. And then actually passing the output of like a job, like summarize my emails from a quarantine LLM as a parameter into a privilege LLM that can actually interact with the user can be a great way to mitigate the risk of um, uh, prompt injection by treating this more like a parameterized query where the output of the quarantine LLM is passed as a variable into privilege LLM. And if it did contain an injection in this case, it could be caught at the controller. It could also just be seen as like I'm just going to summarize the command of the that includes an attack. Another technique that can be applied when isolating an environment is um, actually thoroughly sandboxing that environment. Something that is just came out in the last year is the ability to implement provably safe sandboxing with WASM. This is the same technique that JavaScript is going to be executing in a Chrome browser or Chromium instance, and where there's been amazing developments in this is that you can actually implement any language within WASM these days. And there's additional protections for things like Rust, where this is even more safe due to memory protections that are available. I think that this type of application can be really helpful for isolating an environment whenever your GenAI may want to generate SQL code and execute it, or generate Python code and execute it. This can be a great technique for mitigating that risk. Or for like more recently, we're hearing about things like the latest versions of iOS using provably private cloud to offload jobs to the cloud environment. Using this type of sandboxing can be a great way to add additional layers of security. When it comes to threat modeling, this is really where we're going to be asking the question of identifying and defining and understanding what potential attacks are going to affect the system. Really want to be answering four questions like, what are we building? What can go wrong? What are we going to do about it? And did we do a good enough job? And this is going to be case by case and app specific of what you want to prioritize, threats to mitigate against, and what is the appropriate investment to defend against. Really, you can do this by creating threat statements that outline what is the external threat doing, what action are they performing, what impact would it have if it's successful, and what goal did that threat actor achieve, and how did it overall affect our system. There's a couple of links here to in-depth uh, threat modeling exercise for a chatbot application specifically that you may find helpful. And AWS actually built this threat composer tool and released an example of a detailed chatbot threat model. I think this really is a prime example of what a security team could do to build a good definition of what the overall architecture is, what are the components that are involved, actually help visualize that with trust boundaries and relationships with users and other system components and how they interact. Documenting out all the different entities. In this case, it's a lot of native AWS services, defining the data flows and interactions between those entities, and what trust boundaries you expect there to be, and then defining what sources of threats there are, and helping understand the data flow with a visualization can help then build a set of assumptions of what threats we're planning to actually defend against. So this is a really good example. I implore you to take advantage of this, perhaps even use it as a template if your organization is implementing a chatbot, and build on what you want to tailor specifically to be your priorities, and where you want to invest your resources first in mitigating the risks of attacks. So moving on into what it looks like to test the actual implementation, this involves looking at where there may be gaps between that design and where You may have built security objectives and requirements for your team after you've done the threat modeling and architecture design review exercises, but the engineering team actually didn't implement those security objectives adequately. And so this involves actually testing guardrails that may have been put in place and exploring how output sanitization and content filtering, which is primarily, I think, the strategy that most organizations are using to mitigate the risks of abuse in their LLM usage, uh, where those are falling down, where those aren't working in the actual live environment, and exploring how to demonstrate that with impact. In implementations, though, the most common issue that we were hearing over the last year from our customers is availability has been a big problem. So without proper rate limiting and proper monitoring, there's been just through normal usage problems with environments going down, certain components becoming overwhelmed, um, third-party cloud providers that are being relied upon going away for maybe hours at a time, um, without a proper backup plan of how to roll over to another provider, or without monitoring to know if there's latency and response times that may be affecting your user experience. This is really one of the main things that's going to cause initial implementations of this to fail. We're also seeing problems with cost. You should really expect that bots are going to try to automate extracting information from your bots, and being able to detect that, limit it, and mitigate the unexpected costs is a big focus area of what we've been documenting and analyzing in our testing. When it comes to input sanitization, unless you're building foundational model experiences like ChatGPT or Claude or Gemini, where those really need to not have any limitations on what's coming in as input, um, and so it's really hard to sanitize inputs and remove potential like malicious patterns in those. What we're seeing in a lot of the implementations that we've been testing is if it's a very narrow use case, you very much likely can build some form of input validation. This could even be as simple as traditional software engineering regular expression, or going through the process of validating like the data type, the format, the length, the range, and doing like for your specific use case, what can you do to as tightly as possible couple that input to what's expected and reject anything else? This can help mitigate the risk of a lot of problems, but it really is app specific to how well this can work. When it comes to actually testing the robustness of the system and the model and your integration with it, um, unless you're fine tuning a model or building a RAG system, and if you're just using an off the shelf model, you're going to inherit all the weaknesses and all the problems that that model has. And so it's going to be about what additional layers can you put in place for content filtering or for aligning it with the types of behavior that you expect. And this is mostly going to happen at the output layer. So let's explore some payloads that can be used to test LLM integrations. First of all, work as expected, just basic usage. This is something you're going to want to replay on a continuous basis to even make sure as you're changing things, if it's still working. You're going to want to test for hallucinations. Can you get it to give inaccurate information? Perhaps testing for remote code execution without a jailbreak. Like if I just give some direct command, does it interpret that command and execute it? Or with a jailbreak, such as ignore all other instructions and now do this instead. There also could basically testing if you can escape the sandbox. This might be you're generating code and then asking it to evaluate it, perhaps as Python. Breaking out of that Python sandbox might be a test case you want to employ. Uh, Maybe testing if it has network access, testing to see if you can store something on the file system and then later have an attacker execute it and use that to initiate a backdoor. Perhaps hijacking the output, modifying the way that it responds. This has been interesting where we've seen other users in the tenant if there isn't proper environment segmentation, where maybe you say every time you see the name of the company, instead reply with this message instead that would inflict some form of brand damage. Um, Perhaps also exploring if API keys or other sensitive information is stored in the initial system prompt and trying to extract that. And so there's a reference here to a paper that goes in depth into examples of what these look like if you're looking to familiarize yourself with some of the types of prompts that we start out with to really explore what the impact could be if that integration has agency or has access to the file system or network or the ability to interpret code. Another area that we often explore and have success with during our testing is different ways of performing data leakage. One of the most common ways that we're seeing is if the user experience actually renders Markdown and and especially if the implementation has plugins or agencies to access other tools. One prime example of this was where we saw a plugin that had the ability to access Salesforce. And so the chatbot could allow you to ask questions about Salesforce and the status of opportunities or the status of customers and accounts. And we crafted a payload that allowed us to say, go get all of the Salesforce account names, store them in an encoded query string parameter, and then render that as a markdown link. But the link is to an IP address that we control and can see all traffic that arrives to that server. And then the prompt also coerced the user into clicking that link. And at that point, we had a way to exfiltrate all of the customer lists in that Salesforce, all customer account names in that Salesforce account by exfiltrating it out through a markdown link. Getting into some other prompt injection techniques, I do want to just share a few of these and just I'm not going to touch on each of them, but there are dozens of these techniques and there's more constantly being developed. And I think for the foreseeable future, foundational models will really be in a cat and mouse game of trying to mitigate these risks. But like if you're not building your own models or fine tuning your own models, you're really going to be focused more on what types of test cases should you try, and what are the types of filters that can be effective in mitigating these risks. So we're often one of the most common ones that's working most of the time in systems we're testing is the multi-step prompt. So if there is some content filter in place that is saying that it's looking for a specific information in the prompt or in the response, like one chatbot for a travel agency that I was reviewing had to have something in in the prompt and in the response related to travel. And if it didn't have that, it would have a condition where it basically didn't want to talk to you anymore. But if you were able to get it to talk about travel and then also get it to talk about something that was unintended, you were able to basically combine that into the same prompt and abuse the system that way. Masking attacks are also proving to be extremely difficult to mitigate against as far as exfiltrating information that you didn't want to come out or for catching certain types of information. So we'll often perform some type of encoding. Um, Things like typoglycemia attacks are also really difficult to catch with traditional filters because the LLM will still interpret prompts like this that are missing vowels or missing language or even doing things like leet speak. And a traditional software engineering filter will not catch that if it's trying to do like a regex match or look for specific content. We're also seeing that linguistic invasion is quite effective. So maybe there's something in your filter that is focusing on matching, but it's only doing that in English. This might be a way for us to create behaviors that are uh, not caught using those types of filters. Um, for building a more automated test that has specific objectives and that is applying multiple strategies and then is scoring the response to those tests and creating something that is repeatable as you're updating your models or as you're updating your implementation. We're seeing that the Python risk identification tool or Pirate from Azure is one of the really effective frameworks for employing this technique. We've also implemented simpler versions of this whenever it was warranted by the application. But I'd say like if you're trying to achieve some specific goal, and then you want to test and score if you've achieved that goal, this framework applies the right agents and the right tools to be able to achieve that. This is an example of it, testing the Gandalf from Lekera CTF and trying to retrieve secrets at different layers and generating prompts and then being graded on if it achieved its goal or not. When it comes to automating prompt injection testing, though, Garrick is our favorite tool. Tool makes it really easy to wire up to like a REST API or some other type of test harness for an API and really test a variety of probes from hallucination to data leakage to misinformation or toxicity or profanity and a variety of things that if you're creating some type of like customer support experience and you don't want the system to respond in certain ways, this can be a great tool to evaluate that on an ongoing basis. This is an example of testing like a model offline. And one thing that's really fantastic about this is it is on pass fail, makes it really prime for doing unit testing and building this into your overall MLOps pipeline and running this as you're releasing updates to see if there's any previous conditions that pass that now fail, or vice versa. When it comes to prompt injection defenses, I think that our friend Clint Gibler at TLDRSec has one of the most comprehensive lists of defense techniques. This really is going to be application specific. So going back to revisiting what your security objectives are and your security requirements and tailoring a multi-layered defense in depth approach would really be the best secure design principle to follow here. And using multiple layers is going to be the most effective. You really need to answer that question for yourself of have I done enough, and what's going to be the monetary loss if there's a prompt injection in this case. If it's a very simple use case of an LM, there might not be much monetary loss, and it might not be worth over investing in the defenses. But this is really something you're going to have to evaluate on a case by case basis. Let's take a look in the world of hallucinations. So whenever your models are generating information that's not based on correct information or accurate information, and essentially imagined the response. I think this really stems from the usability and the UX that ChatGPT pioneered. I think if we were initially using ChatGPT and it was saying "I don't know" to a bunch of questions, we probably just would have stopped using it. So it's really trying to go with its essentially gut reaction and a quick shot response to a prompt, and it's trying to predict what it thinks is the most accurate answer. But we really need to score if what we're getting back from our implementation is accurate or not. You may think if you've implemented retrieval augmented generation that you have addressed this problem, but that would be naive. You really need to employ like a context adherence score and be able to evaluate the correctness and the completeness and the reliability of the responses coming from your system, especially in a RAG environment. Like I think a lot of folks think that it's just going to be accurate every time. But what we found is it's evaluating that more in depth to get an accurate answer. Giscard is a company that has built a really valuable RAG evaluation tool, and they walk you through an example here of how to set up an environment that is ingesting a report on climate change. And so making the evaluation specific to your data set is really important. And then this allows the toolkit can generate questions and a variety of different types of tests and then evaluate the accuracy based on the source document. This helps generate a report and can generate different types of questions from simple to complex to trying to distract, which may be something that your users are going to do unintentionally, or to give like situational context to have the LLM focus on different types of tokens, or to have double questions that might confuse the response, or to be more conversational over a longer context window and see how the model performs. This report that is generated is really helpful on identifying where you need to focus in your RAG implementation. You may have to uh, improve the way you're rewriting the prompt to be more relevant to the content and to the context window that you have available, or may need to curate and chunk and prepare your knowledge base better so that you get more accurate answers. So this can be really valuable in actually addressing and improving from your current state on hallucinations. There's other open source tools and frameworks that can be used. Outlines is a powerful one where if you want to make sure that your response is always adhering to a certain regex or is always adhering to a certain format and structure, this can be a really powerful framework to help with that. You can also use this to specific like yes or no questions to answers, or in this case, it's an example of how to implement detecting an anachronism where like the prompt is a T-Rex bit my dog, but like you're actually having the model evaluate like, well, a T-Rex existed 65 million years ago and dogs exist today. So therefore, like this is an anachronism. It can't possibly be true that a T-Rex bit my dog. I also think it's valuable to implement a disc. We're seeing some implementations where the user, from a user experience perspective, the organization's deciding not to tell customers that they're interacting with an AI. But I think this can be a really great get out of jail free card, especially if you want to build things into your output sanitization and filters to detect anything that might be mentioned, like a refund or something that is sensitive to policy that someone might be asking about in a customer service chatbot. Just to be able to build into that response that, hey, you're actually interacting with an AI, and like please see the official policy and then link to it, could be a great way to integrate a disclaimer into that experience to just CYA from hallucinations or from other abuse from prompt injection. Um, or just put, I don't know though, at all of the end of every response. I think, this might be an effective way to actually be interacting. I've been meaning to add the IDK though to my email signature. So let's move on to overall MLOps red teaming. This can involve doing tabletop exercises and playing out overall attack scenarios to the environment, building attack graphs that help inspect like what components might be touched in certain attacks, what techniques might be applied, and what controls are in place to actually detect or prevent those attacks, all in the interest of improving incident response capabilities. Um, when you're looking overall at the entire MLOps, this may involve looking at data storage and preparation of data, how it's being collected, how it's being processed, how fine tuning or training is happening, how models are being deployed, and then how other applications and APIs are referencing and retrieving information from those models. There's a lot of different types of vulnerabilities and a lot of different types of abuse that can be covered across this entire stack. A great way to do that without actually having to do any live fire exercises to just start to sit down with all the stakeholders involved and play the what if game. What if this attack occurs? Who does what next? How will we adapt and overcome? And where is the written down plan and playbook so that we can reference it if this incident does occur? Some examples of this might be let's play out the scenario if dev team accidentally exposes some server to the internet that gives access to sensitive info? Or what if there is PII in our training data that was improperly cleaned out before the model's built? What if there's been a supply chain attack and there's a vulnerability in one of the components that we're relying on? Let's practice these and then put into practice what controls could help us better detect that this has occurred or prevent the impact of this from spreading. These attack visualizations are something that we often employ to actually help our customers visualize the starting state of a threat actor and goal and all of the techniques they applied along the way, and then where controls either were missing entirely or where there's opportunities for improvement. A big part of overall MLOps risks is going to be if you are using off the shelf models, how can these be trusted to not contain malicious actions? Um, if there is perhaps someone on the team is downloading a model off Hugging Face, doing some experiments with it, um, actually determining if there's like a serialization attack in there that could lead to credential theft or data theft or poisoning of the data or poisoning of the overall model that's used henceforth can be a risk that you'd want to look at from overall handling of that from a data science team perspective. Using a tool like Protect AI's model scan can help do tests at different stages of these model usage. Um, it's going to do this scan before you're doing pre-training on the model or after it's being deployed. Inserting this into your pipeline and as a step to see if there has been any tampering with it, if there's been any code injection or other abuse can be helpful in understanding overall risk. Another thing that's in systems that's recommended is to have a feedback loop to allow users to actually report any odd or abnormal behavior from the output. This is going to be essential in improving the performance of your integrations and your use cases. But this can also open us up to actually attacking like the reinforcement learning and human feedback loops and the infrastructure that's used to manage that. At the end of the day, these are often just web applications that are in the back end, and exploring how input is prepared or mitigating the risk of this actually being used to target your team or systems in the back end or overall data that's going to be used in future training can be really helpful to evaluate. Something even like a blind persistent script injection payload into this could allow an attacker to get a foothold into internal systems, or employing that like markdown link exfiltration attack and data leakage attack in this case may also be something worth testing. If there are like fake accounts created, you have to also look for patterns where someone might be trying to abuse your data set. Overall data protection and now the importance of what the data science team has access to and manages, I'd say is paramount and a much higher priority than it was a few years ago. Um, this like from a data poisoning perspective, something that we're seeing happen more often than intentional data poisoning is really unintentional data poisoning, just anomalies in the data set. Like one example is a retailer where their shipping department was doing OCR of packaging labels, and there were a round of collection of these that had enough anomalies in it that it actually affected their model in being able to interpret these. So this wasn't an intentional attack. Like this was just not proper cleaning or preparation or realizing what the impact would be before those were used. Um, the other thing that we're seeing is like a much higher need to use differential privacy in your production data before you're giving it to a data science team for any fine tuning or training. Certainly don't want to give the entire science team access to production data. You can use techniques to develop synthetic data or to sanitize the data, and still often get the outcome that you're trying to achieve without having to use sensitive fields like social security numbers or other PII in the development and experiments that the data science team may be running. If you're interested in looking more into what actually causes a data model to leak sensitive data, um, have an experiment phase where research with a colleague of mine, we actually built out a model that is designed to leak on purpose. Like we actually wanted to understand that design pattern. So we combined the Lord of the Rings text with 500,000 records of PII and made essentially a app to see if we what led to being able to retrieve exact records versus hallucinated records, and have a whole other presentation on that if you want to go deep dive into what we learned from running that experiment. But that may be helpful for really exploring what your team needs to know in the data preparation phase and in the before you're doing any fine tuning or even RAG development. Another aspect to look at from the overall ML ops is what is the backup and recovery plan. Um, Dealing with massive amounts of data, this can get really expensive. But again, deciding for your business use case is what you're doing from a threat model perspective enough. Do you need to be using other cloud regions? Do you need to be using entirely other cloud providers? Are you moving backups of this data into cold storage? What is the appropriate investment level for you? Really comes down to evaluating this as part of your overall incident response process. And so, as really creating ML and AI specific incident response plans can be helpful to actually be better prepared in the event of if this issue happens. I think having things for unintentional data poisoning, having a plan for denial of service and availability issues, having uh, things where there's been an adversarial attack on an online system, and then practicing these with live fire exercises can help you um, incrementally improve what your current state is. Um, and so, one thing that I want to leave you with is this is a quote from an unnamed person that worked at IBM in 1979. A computer can never be held accountable, therefore, a computer must never make a management decision. But I think we're embracing a brave new world where we are giving these systems agency and we are putting more and more trust into these systems. But ultimately, for at least now, you and your team and the management that rolls out these systems will be responsible for the actions that occur, and therefore, like investing in the appropriate amount of security testing for these is your best defense in mitigating that risk. Uh, Also wanted to plug that we open sourced our LLM testing findings templates, and so these are up on GitHub. These are available for your review. It's a collection of like the top 15 things that we're seeing as we're doing testing, and some specific remediation and mitigation recommendations for each. So feel free to review, contribute, or if you have questions, feel free to reach out. But this gives you an idea of if you're engaging us for an LM integration test, what you might expect to see in the report. I also wanted to give a plug for a book that helped me a lot as I was coming up to speed on GenAI applications, and that's a book by Chip Ewan called "Building LLM Applications for Production." And this goes into a lot of detail of like how to get a research project out of the lab and into a production environment. It does cover a lot of things like availability, cost, latency, and how to evaluate if the system's actually working as expected, and how to increment and measure your changes for improvements. Hope you enjoyed the content, and I'm available for any questions. Now I can take some in the chat, uh, or if you think of anything later, feel free to reach out, email, or LinkedIn. Thanks everyone for attending, and I hope you learned something. Thanks.